In the hushed expanse of the universe, where ambitions soar like comets only to shatter against unseen barriers, envision a colossal dream unraveling in flames. A rocket, forged from human defiance, erupting into a cascade of fire that echoes the birth pangs of stars gone supernova. It begins with a whisper of doubt. What if the very vessel meant to carry us to crimson horizons crumbles under its own might, scattering debris across the void like ancient stardust? Consider the paradox. A machine designed to conquer gravity, fueled by methane drawn from worlds beyond, yet vulnerable to the tiniest flaw. A misaligned trajectory, a booster's furious overload, turning triumph into tragedy in mere seconds. We've seen precursors, like the thunderous demise of prototypes where explosions lit the Texas sky brighter than 1,000 suns, releasing energy equivalent to 10 tons of TNT. This is the enigma of Starship, a behemoth promising Mars by 2030, but shadowed by the specter of failure that could redefine our cosmic fate. We ponder this precipice, where ingenuity dances with peril, leaving us to wonder if the stars we reach for might instead consume us in their fiery embrace. Imagine the grand arena of Boca Chica, where the flatlands stretch like an endless canvas under the relentless Texas sun, and the Gulf's salty breeze carries the metallic tang of innovation. Here, Starship stands as a towering sentinel, its stainless steel form gleaming against the horizon, a structure that rivals the height of ancient pyramids, yet pulses with the energy of a contained storm. This is the stage for potential catastrophe, where the super heavy booster, laden with 33 Raptor engines, crouches like a mythical beast ready to unleash its fury, each engine capable of generating over 230 tons of thrust, enough to propel a small city skyward. The scale is breathtaking. The entire stack measures 120 meters, dwarfing the Falcon 9 that has ferried astronauts to the International Space Station, and its methane-oxygen propellant load exceeds 5,000 tons, a volatile sea that could vaporize in an instant if containment fails. Contrast this with the serene beauty of Mars, the red planet that beckons 225 million kilometers away during optimal alignments, its thin atmosphere a mere 1% of Earth's, offering no forgiveness for errors in descent. In simulations, we've mapped these risks, visualizing trajectories that veer off course, where a single engine hiccup at Mach 5 sends the vehicle tumbling like a leaf in a galactic wind. Emotionally, it evokes a profound reverence for the fragility of progress. The launch pad, scarred from previous tests, mirrors the craters of the moon, reminders of impacts that shaped worlds. Philosophically, this landscape expands our understanding of scale. Black holes lurk billions of light years distant, swallowing light itself. Yet here on Earth, we toy with forces that could mimic their destructive grace. The orbital refueling dance, intended to multiply payload capacity tenfold, introduces hidden perils, cryogenic transfers in microgravity, where a leak could trigger flash freeze or explosive boils, contrasting sharply with the steady rhythm of our planet's tides. As we immerse in this setting, the wonder deepens, for Starship isn't merely metal and fire, it's a vessel of human aspiration, set against a cosmic backdrop where failure isn't an end, but a teacher in the art of resilience, urging us to gaze beyond the immediate blaze to the enduring light of possibility. Beneath the roar of ignition, where flames lick the sky in defiant arcs, lurk the hidden signals of impending doom. Telemetry pulses racing through fiber optic veins, capturing the subtle tremors that precede catastrophe. These are the unseen harbingers, pressure spikes in the Raptor engines, detected by sensors embedded like vigilant sentinels, revealing fuel imbalances that no human eye could discern amid the exhaust's blinding glow. In shocking simulations, computational models replay these anomalies, showing how a turbopump failure at 10 kilometers altitude cascades into asymmetric thrust, twisting the booster like a serpent, uncoiling in agony. Radio waves from ground stations intercept these cries, decoding light curves of thermal emissions that spike erratically, much as astronomers trace gamma-ray bursts from distant neutron star collisions. The intrigue builds with explosion risks. Methane's volatility, when mixed with oxygen in a rupture, ignites deflagrations propagating at 300 meters per second, captured in high-speed footage where shockwaves ripple like invisible tsunamis. AI algorithms, trained on petabytes of past launch data, predict these trajectories, adjusting in milliseconds to simulate evasive maneuvers, their neural networks mimicking the brain's intuition, but scaled to cosmic precision. During suborbital tests, accelerometers log vibrations at frequencies up to 1,000 Hz, anomalies that whisper of structural fatigue in the Super Heavy's grid fins, invisible strains echoing the seismic precursors of earthly quakes. The wonder intensifies as we realize these instruments extend our perception into realms beyond sight. Infrared scans unveiling hotspots on heat shields, where tiles crack under 1,600-degree re-entries, signals that build a narrative of vulnerability. It's akin to deciphering a celestial code, where each data point is a fragment of a larger puzzle, revealing how a mere 1% deviation in trajectory could scatter debris over 50 square kilometers, turning ambition into a cautionary tale woven from the threads of science and fate. In this tapestry of risk and revelation, a gentle warmth emerges, connecting us intimately to the star's embrace, evoking shared humility as we reflect on the dreams that propel us, fragile yet unyielding in their emotional depth. Journeying back to the primordial sparks, we reconstruct the origins of these perils, tracing the elemental forces that birthed Starship's design amid the chaos of early rocketry. In the 1950s, the dawn of the space age saw V-2 rockets collapse in fiery spectacles, their alcohol fuels igniting uncontrollably, lessons etched into the genetic code of modern boosters like Super Heavy. This genesis mirrors the universe's own turbulent birth. Just as the Big Bang's plasma cooled into galaxies over 13.8 billion years, Starship evolved from Falcon prototypes, each failure a collapse birthing stronger structures. Consider the Raptor's methane heritage, drawn from ancient stellar nurseries where carbon atoms fused in supernova forges, now channeled through full-flow combustion cycles that achieve 380 seconds of specific impulse, efficiency born from eons of cosmic chemistry. Philosophically, it's a nostalgic echo of fire's dominion, from cavemen taming flames to engineers wrestling with cryogenic propellants at 183 degrees Celsius, where even minor impurities trigger boil-off explosions akin to volcanic eruptions. The Super Heavy's origins lie in iterative designs, starting with 2016's Interplanetary Transport System concepts, slowly forming order from chaos. Prototypes like SN1 imploded under tank tests in 2020, their stainless steel skins buckling like ancient ice sheets fracturing. Extended reflections reveal how these beginnings embody entropy's grip, disorder lurking in every weld, every valve. Much as black holes form from stellar remnants, their event horizons swallowing light. Deeper still, explosion risks trace to fluid dynamics rooted in Navier-Stokes equations, formulated in the 19th century, yet applied here to model methane sloshing in tanks during ascent, phenomena that parallel oceanic currents shaping Earth's climate over millennia. Orbital failures hark to Apollo-era simulations, but Starship's scale amplifies them. A refueling mishap could mimic cometary impacts, scattering icy shards across orbits. In this mythic immersion, time unfolds rhythmically, each test a stanza in an ancient epic, where primordial dust coalesces into resilient forms, reminding us that from collapse emerges the potential for rebirth, a philosophical bridge linking our earthly origins to the star's unforgiving void. Astronomically, we ponder Mars' own ancient cataclysms, volcanic outbursts that dwarf Olympus Mons, the solar system's tallest peak at 22 kilometers, mirroring the booster's potential for self-destruction, yet inspiring backup plans that harness AI to rewrite trajectories, turning peril into pathways forged from the universe's enduring elements. Science unfolds as a custodian of memory, preserving the ghosts of past failures in this vast data archives, where simulations of Starship catastrophes read like illuminated manuscripts from the cosmos. Ancient light from exploded prototypes captured in high-definition videos allows us to dissect shockwave propagations, much as paleontologists unearth fossils to reconstruct extinct worlds. Particles from debris fields, analyzed via spectrometry, reveal material stresses endured at 10 GE forces, echoing how we decode cosmic rays to trace galactic histories. In this poetic blend, computational relics, finite element models predicting booster ruptures, serve as time-bound artifacts, their algorithms evolving from 1980s supercomputer runs to today's AI-driven forecasts that anticipate failures with 95% accuracy. Lyrically, it's the art of listening to echoes across epochs, merging clarity with the rhythm of relentless inquiry. Voices from the scientific chorus amplify these tales, with NASA's Ames Research Center running simulations of Starship explosions. Their 2D22 studies in the Journal of Spacecraft and Rockets detailing blast radii exceeding 1 kilometer. Researchers like Dr. Philip Metzger, analyzing trajectory adjustments via AI, draw on Perseverance rover data for Mars analogs. Missions such as the 2023 Integrated Flight Test expose Raptor vulnerabilities, timelines from 2019's Starhopper to projected 2025 orbital attempts, weaving human precision into a symphony of progress, respectful and grounded in empirical harmony. Venturing into invisible landscapes, we explore the subsurface tensions within Super Heavy, where quantum fluctuations in fuel lines hide instabilities that amplify into explosions, densities rivaling white dwarf interiors. Beyond, dark energy's cosmic push subtly alters trajectories over interplanetary distances, analogous to economic undercurrents funding these ventures. Metaphorically, it's delving into abyssal depths, where pressures forge unseen strengths. AI predictions map these, contrasting microscale turbulences with macro-orbital drifts, evoking awe through fluid comparisons of chaos contained. Life endures in defiance of catastrophe, much as microbial survivors in Chernobyl's radiation zones parallel potential Mars colonists adapting to failures, where AI-optimized habitats recycle air with 98% efficiency despite dust storms. This wondrous persistence mirrors human resilience, from deep-sea vents teeming with extremophiles at 400 degrees Celsius to astronauts training for contingencies, inspiring reverence for biology's quiet triumphs in hostile realms. Broadening our gaze to refuge worlds, Europa's subsurface ocean, heated by tidal forces, offers havens where life might thrive amid icy cataclysms, shocking with hydrothermal vents richer in energy than Earth's. Titan's hydrocarbon seas, Enceladus's geysers ejecting organics at 1,900 km. These evoke hopeful expansions, facts of potential biosignatures weaving into emotional tapestries of alternative sanctuaries should Mars dreams falter. Amid this interplay of ambition and abyss, tension heightens our awareness, sharpening focus on the delicate balance, where each simulated failure echoes our need for vigilant stewardship in the cosmic narrative. Human scars reflect these stellar perils, as industrial mishaps like the Deepwater Horizon spill parallel booster explosions, leaking methane that warms the globe 80 times more potently than CO2. While societal overreaches from Roman aqueduct collapses to modern deforestation mirror mission risks, fostering empathy in our quest to avoid repeating history's resonant wounds. Collapse accelerates in visceral simulations, where Super Heavy's rupture unleashes a fireball expanding at 2,000 meters per second, debris raining like meteors, mirroring climate tipping points with glaciers calving into oceans, floods surging with multisensory fury, roaring blasts, acrid smokes, grounded in poetic realism of unraveling systems. Beneath the surface, hidden stakes entwine political rivalries, as U.S. export controls on AI tech clash with China's lunar ambitions. Economic drives for asteroid mining trillions, conflicting with moral calls for global cooperation. Historical echoes of Sputnik-era tensions analogize today's, weaving motives into contemplative patterns of shadowed advancement. Futures teeter on the edge. One dystopian path sees Starship failures cascading into abandoned Mars hopes by 2030, Earth choked by unchecked emissions. The other, hopeful, leverages AI backups for resilient colonies, sustainable fuels from algal bioreactors, personal responsibilities lifting us toward renewal in visionary sobriety. In this stirring closure, symbolic echoes loop through our introspection, binding the narrative in sincere quietude, a resonant arc of human endeavor. What lingers, mirroring the initial enigma, is the profound question: If failure claims our celestial chariot, will it extinguish the fire of exploration or kindle a wiser flame across the void? In the legacy of light, we reflect on humanity's odyssey, where Starship's potential failures illuminate species-level ethics of survival, framing long-view metaphors from civilization's rises and falls, Mayan ruins whispering of resource hubris, to urge ethical inscriptions on the stars, ensuring our light endures through generations.